So I hope everyone is ready. Your computer is ready in front of you. And in a couple of, we are going to start with this practical session of the training of what we did yesterday. So I will be sharing my screen now. So guys, get your stuff ready, get your computer ready, your application ready, open it up so that immediately we start, we are kicking off with the training. So let me share my screen with you guys. Okay. Okay. So that is the interface of interactive petrophysics. That's the interface right there of interactive petrophysics. Now, I want us to first of all look at the interface. I mean, this is, you know, if you have used one or two softwares before in either petroleum or GIS or whatever software, even if it's Microsoft Word or Excel, you realize that the interface are always the same. So it's not different from I think, please, is there any other person who said it's not, you can't see my screen? I'm sure you guys can see now. I had not shared before, so I'm sure, but if you cannot see my screen now, please just let me know. Just indicate, please. Okay, so the interface for softwares are always almost the same, in almost the same case, like in most software that you've seen before. The first thing that you see here is your file. If you navigate, if you click on file, you will see new database. And within that new database, it means that you can create a new database that whatever you are doing within this software, all the work that you will be doing will be saved in that new database. So this is where you create a new database. If it's your first time of using that particular data using this software, then you are going to create your new database in that area. And then when you leave from new database, you go to open database. With open database, that means if you have an existing database in your IP, in your interactive petrophysics software, you just go ahead and open that database. So this is where you open a database. The next thing here is create database shortcut. So if you click on this create database shortcut, what will happen is that it will just create you a shortcut of all the work that you have been doing. So next time, if you want to open that the old work that you have been doing on IP, you will not go back to the software and then go back to open database. No, you just go to your desktop and double click on that shortcut, and your database will just open with every work that you have been doing inside. So you can set default location, you can explore database, you can save. This is when you want to save. As you are working, you need to be saving all your wells. You can save current wells as, or you can save all wells. That's in the case where you're working in more than a single well. So many people can't see my screen. What's the problem? So just give. Okay, thank you very much. Thank you very much, guys. So, like I was saying, still on file, you can save all wells to database. You can save current well. That means if you are working on a single well, in the case where you have so many wells. Another thing is that you can do autosave. So you give it a particular time, like you want to save every after 15 minutes, every after 10 minutes. That's what, if you click on this icon on autosave, it's going to tell you how many minutes do you want to save. at how intervals of how many minutes. That's why you see 3. There you can click on this button and increase it to 10 that you want to save in an interval of 10 minutes. So that's autosave. So you can print whatever you've done. So the next thing here is well. We are going to see, or we will be using all these parameters on wells as we move on. You have input and output. This is where input and output is where you load your data. So depending, you and I know that usually well logs come in 2 data formats. We have the ASCII format and the LAS format. So depending on the data that you have, that's the one that you are going to choose to load for your loading. So if your data is ASCII, select ASCII to load, please. If your data is LAS, select LAS to load. But remember that this data that you and I are going to work on are LAS files for today. So we'll be using LAS files for today. Still, you have edit. You can edit whatever you've done. Okay, so you have still there. You have load data. You have save data. So if you have done all your work in IP and you are satisfied, you can export your results and take them to Petrel and complete and build a model of the reservoir that you are trying to model. So that's it. So this is where you save everything, and then you can now take that data to Petrel. You can edit your work, you can view, depending on what you want to view, you can do calculations, you can do interpretations. A lot of interpretations. We'll see that as time goes on. So all of these parameters, we can use them. So you can still see them right there. Advanced interpretations, log plot, multi-well, tools, user programs, well, and then you have a help section. Remember that this help section is here for you to use it anytime that you want, guys. Once you go to help and you go to help manual PDF, you would check anything you want to do. You just go to help manual. It will help you to navigate this software, even though you must need some help from someone to tell you how to easily navigate. But help manual will also tell you easily what to do with your software. Okay, so we are going to look at our data. We'll take a look now at our data. We'll take a look at our data. This is our data. This data is opened on Notepad. So our data is open on Notepad. When you look at our data, you see that we have the well information right here. We have the well information, the start depth, the stop depth. We have the composite, the oil, the field, the log, the country where the data is coming from, the state where the data is coming from, the Niger Delta. Every information, when this well was drilled, you check and see. And then as you go down, you see the various logs that were measured. So you see that we had the resistivity, the sonic, the DT, the gamma ray, the raw B, the temperature, and then the neutron. All the logs that were measured will be down here. That's the way your raw data looks like. So if you've never seen a raw data before, that is the way your raw data looks like, with all header. Every information about this data is right here on the header. So now we are going to start with the software proper. We are going to start actually with the software proper. So the first thing that we are going to do is to create a database. Like I said, there is nothing you can do without, first of all, creating a database. I hope everybody is following. I hope that everybody is following, because we are going to move from one step to the other so that people will get to understand and they will follow the process step by step. So the first thing is to go to File. So are we on File? So if we are on File, you click on new database, because we can't do anything without creating our database. Every other thing that we'll be doing on this software will be saved in this database. So we need to create it on this database. So you click on new database. You click on new database. So when you click on new database, this dialog box is going to open to you. This dialog box is going to open. So they said select or enter the location for the new database. So you need to select in your computer where you want to save this data, where you want to locate your work and save everything that you'll be doing. So you go and click on browse. You click on this browse. So you go and click on that browse, on this browse. Once you click on browse, you yourself, you will navigate and look for where to save your data. You will navigate your computer and look for the best place to save your data. Normally, I will save my data usually on my computer. I will save it on Drive C, because I believe that Drive C is the place where I can keep my data safely. That folder where I will be doing interpretation will be very safe in Drive C. So I'll open that Drive C. Remember that I've just opened Drive C. And then within Drive C now, I am inside Drive C. Drive C is highlighted, that's it. I am inside Drive C now. I can now make new folder. I can create a folder now in Drive C. So I know that whenever I'm looking for my data for this particular project, I move directly to Drive C. I open Drive C, I will see a folder. So I will click on make new folder. So once I click on make new folder, that's a folder. I will give it a name that I will remember. I can call this Petrophysics Practical. Petrophysics Practical. I'll call this Petrophysics Practical. And then the folder is already created. You can just look for everywhere out there and click on top. And your folder is created, Petrophysics Practical. So that is it. And it is highlighted. Remember that that folder is created and highlighted. If you don't highlight it, if you click OK, it will not pick that particular folder. You must highlight it like this. So you click OK, and you have it there that Drive C, that this folder you have created is in Drive C, and the name of the folder is Petrophysics Practical. The name of the folder is Petrophysics Practical. Once that is done, you can now click OK. You can click OK. So they are telling me to save wells in database because there was an old work that I was doing before that they are asking me if I want to save that work. But for you, for your case, if you have not done any work before on IP, there is no need. This information will not come. So there is no need. If you click OK, everything will just go for you clearly. But for my case, I'm going to have this information, and maybe I will take yes or no, whatever the case. But once I take that, I will see now my project folder will appear here, Petrophysics Practical. So that is the first step. You need to create a new database. That's the first step. If you don't create a new database, there is no way you're going to proceed. So after creating a new database, the next thing that we want to do is to load our data, because we want to start working on our data, and we can't work on our data without loading that data. So we need to load our data. And I said it here before. How do we load our data? We load our data by going to input and output. So once we go to input and output, we go to load data. We have already asserting that our data, and we are very sure that our data is a last file. It is not an ASCII file. Please take note of that. If your data is ASCII, you will not be able to load it on last. If your data is last, you will not be able to load it on ASCII. So our data is last file. So we are going to load it as a last file. So we go to load data, we go to last LBS load, we click there, and we go and search for our data. I don't know where you kept your data, but you, in your own computer, you know where you have kept your own data. So you go and search for your data, where you kept it. I am searching, my data is inside my flash, so I will go to my computer, go to my flash drive, USB drive, and my data is right there, sample 2. My data is right there, sample 2. Once I see my data, I highlight my data, I click open. Once I click open, my data, I will see my data right here. My data is telling me that you have, my data is telling me you have depth, the depth, you have the various logs that were measured, you have BVW, effective porosity, PEF, which is photoelectric factor, resistivity, sonic, SWDT, volume of shale, gamma ray, density, temperature, sonic log, and SP log. Now, because this data has been used before and calculations have been done, that is why you have effective porosity, BVW, things like volume of shale. We are not supposed, these are calculated values. The original data that was taken from the well are things like resistivity, sonic log, the DT, gamma ray, density, temperature, neutron log, and spontaneous potential. Every other thing that is here, BVW, effective porosity, is calculated, is because this data has been used before, has been run before for some calculation. But you and I, we want to do our own calculation that has nothing to do with what we have here. We want to interpret this data from crash. So what we will do is that we will just go and remove all of these calculated values. For example, bulk volume water, which is BVW, we'll untick it here. So it means that we are not going to load it in our data. We are going to untick effective porosity, because this is calculated. We will calculate our own effective porosity. We are going to remove we are going to remove water saturation right here, SW, which is water saturation. Please, if you don't get anything, just leave a message. I will look at it. So if you don't get anything, please just leave a message. Yeah, so it's not sonic, it's shear resistivity. Sorry for that, please. So we are going to remove SW, which is water saturation. We are going to remove volume of shale. We are going to remove, okay, that's it. So we are removing BVW, bulk volume water. We are removing effective porosity. We are removing volume of shale. So that's it. So just untick those things that have to untick like that, guys, because we don't need them. And we are also going to remove temperature, because temperature values are usually calculated values, and we will get them. I will give you the values, but each time you go to ask for data, please always ask for temperature values. Always make sure that you ask for temperature values. The industry, the company that is giving you the data, they will always provide you with temperature value. So for this work, let's just untick temperature. Okay. So you can screw it down. You see where I'm trying to screw it down. You can screw it down like that, and then once you are done, you check everything. The units are in feet, and measurements are taken every 0.5 meter. The top depth is 8,900 and the bottom depth is 9,400. Once you check that everything is okay, you click on load. And you see last file sample tool loaded. So that's it, you have loaded your data. So that's all about loading your data. And once you load your data, the data will appear right here. The data will appear right here on your ID. You come right down and click on close. You close it because you have loaded it already. Okay. Okay, so once that is done, the next thing that you and I are going to do is to view our well log. We have loaded our well log. We want to display our well log. We want to see our well log. So what do? You come to this point. You see there is a box, an arrow here that you can drop it down and a dialog box will open. So you click here, it will drop down that. It will drop down that log that you just loaded. Now you go to log plot because that is where we want to we actually unload those parameters because those parameters are calculated parameters. So somebody just asked a question that why are we unloading those parameters? Those parameters are calculated parameters which you and I are going to calculate. If we do the interpretation to the end, you and I can calculate our own water saturation. So we don't need that. That is why we remove those parameters. That's the reason why. I hope you understand that. Okay, so now if you go to log plot, if we want to display our log, we just loaded the log, so we want to display it. So if you go and click on log plot, you take that drop down right there. It's going to give you will see default plot, IP default, and project. So we want to see the default plot, the default log plot that we have just loaded. So you just click on default plot. There are so many ways. You can right click and click on view plot, or you can just pick it right here. You can just hold it with your mouse and drop it on this empty space, like what I'm doing. You just pick default plot, you drop it on this empty space. Once you drop it on that empty space, a dialog box is going to open. So once this dialog box is open, you go to file. There is a file now, not this file up here, please, not this one. There is a file on this dialog box that we just opened. You click on that file and go to program default because you want to display your log. And there are different ways of displaying a well log. So you can display well log either as 3-track blank, 4-track blank, composite CPI, density neutron shading, density neutron, image analysis, lean log, lean blank tracks, resistivity sonic, or triple combo. So these are different ways in which, based on the study with which you are carrying out, you can display your well logs. So there is no standard format. It depends on what you want to do with the kind of work that you are carrying out. So there is but what we are going to do here, because we want to do interpretation and pick out our reservoirs, we are going to do a triple combo, because triple combo will give us the lithology track, the resistivity track, and the porosity, where we can identify the rock type, We'll go further to identify the hydrocarbon and even the type of hydrocarbon. That is why we are choosing triple combo. So you need to know that. So you click on triple combo and your lock is displayed. Your lock is displayed like that. Please remember, you can expand it like that. You can maximize it by just clicking like that. You will maximize your lock. Once you click there, you maximize your lock. You can maximize your lock by just clicking there like that, and everything will come out. So this is your lock. Your lock has been displayed. The next thing that you want to do is to scale this lock. This lock must be scaled. If not, you don't know, because you don't know if this is the right scale that has been chosen for this value. Scaling is very, very necessary. If you don't choose the right scale that best fits the lock, then there is going to be an issue. So we need to choose the best scale for this lock. So how do you choose the best scale? You choose the best scale by going to look at the values of measurements that were taken, the maximum and the minimum values of the measurements that were taken. That's from where you decide what scale you are going to use. And how do we know where the maximum and minimum values of our measurements are? We go to well. I told you that we are going to come to some of these things with time. We go to well and click on manage curve headers. This is where we go to observe the maximum and minimum value so that it will give us the best value for our scale that we are going to use for this work. So we click on manage curve headers. So once you click on manage curve headers, you have general, you have description, you have statistics, you have history, and then you have display. So general will just give you the various types of logs that you loaded. Description will just describe, will give you the description of those logs. And then statistics, this is where we are going to decide which log, which scale we are going to use on statistics. So we know that the first track that we have there is gamma ray. So we want to choose the scale for gamma ray. So gamma ray, we see that the minimum value for gamma ray here, the minimum value for gamma ray here is 19.182, and the maximum value is 165. So if the minimum value is 19.182 and the maximum value is 165, and the scale for gamma ray that you and I know is 0 to 100, 0 to 150, and 0 to 200. That's the scale, that's the standard scale for gamma ray. Then the best scale that we are going to use, somebody already wrote it on the message section, is 0 to 200. Thank you very much for that. For that. So the best scale for this, so that we include all the values of gamma ray within this log, is going to be 0 to 200. So we are done with gamma ray. So the next thing that we are going to look at is resistivity. So when you look at your resistivity, we know that our resistivity scale usually range from, it's a logarithmic scale. So if resistivity is 0.1, then the next, your right should be 10. If it is 0.1, it should be 10 or it should be 100. The right will be 10 or is 100 or is 1000. If it is 0.2, your right scale should be 20. It should be 200 or it should be 2000. But if it is 0.3, your left scale, your right scale should be 30, 300, or 3000, and so forth. So the best scale, when you look at this resistivity lock, the best scale that we can use for resistivity is 0.3 to 30. Because when you use 0.3 to 30, you are going to have a scale that just fits that particular size, and all the values are going to fall within that range of 0.3 to 30. I'm not saying that 0.2 to 200 is wrong, please. It's not wrong. Even 0.1 to 100 is not wrong. It's correct. 0.1 to 100 is correct. 0.2, you see that when you look at the minimum value is 1.96. The maximum value is 28.15. So if you use 0.3 to 30, all the values are going to get in there. So you can use 0.1 to 100. You can use 0.2 to 200, but it's not going to be the best scale that fits everything in place. So the same thing with your density. Density is usually a difference of 1. The scale of density is a difference of 1. So in the case of density here, we can use 1.65 to 2.65. And sonic log is usually 0.6 to 0. So it depends, or 0 to 0.6. We can always use that for our scale. So if we have accepted on that, then we are going to close this, and then we go back to our log. Now, how do we correct our scale? We correct our scale by going to the scale bar. Where my mouse is what we call the scale bar, So you go on the scale bar and click on the scale bar. You click on the scale bar like that. So once you click on the scale bar, a dialog box is going to open. And you go to gamma ray, and you say the left scale is 0. You leave it like that is correct. And the right scale is 200. You change it to 200. And most of the time, gamma ray is usually blue. Gamma ray, they use blue for gamma ray, the color for gamma ray log. They use blue. So it doesn't mean that you can't use green, please. There is no rule of thumb that you must use blue, but most of the time in the industry, people use blue. So once that is done, what do? You click apply and take yes to all, and then you take OK. You take OK. So you have corrected your scale for gamma ray log. Okay. So the reason why we are not looking at the other SP is because we know that we have gamma ray. Gamma ray can tell us everything that we want to know about lithology. So that's why we really did not go into SP. So the next thing is your resistivity log. So resistivity log, you click still on the scale bar, and you go to resistivity and change. We set 0.3, but we still remind you guys that 0.2 to 200 is not wrong, but it's not the best scale that fits resistivity for the maximum and for the minimum and maximum values. So you choose 0.3 to 30, and then you click apply and take yes to all and take OK. So that is the best scale for resistivity. Okay, now we go now to porosity track, which we try to find the best scale for neutron and density. So here we said we can use 1.65 to 2.65. It doesn't mean that 1.95 to 2.95 is wrong, guys. We are looking for the best scale. And then CNL, we can use 0.6 to 0. 0.6 to 0. When you do that, you take OK, you apply, and then you take OK. So that is it. That's our scale. This is our log. I mean, it's coming out clearly. You and I can already start making sense from what we did yesterday. We can already start making sense of this interpretation right here. We can already start making sense of it. So the next thing that I want us to do is to do a cutoff so that we'll see a clear cutoff for what is sand and what is shale. So that's the next thing I want us to do. I want us to go back to Okay, somebody is asking that what is this curve? This curve is just trying to give you particular depth. It's just trying to give you that this is how the curve look like at this depth, at the depth of 9,000, at the depth of 9,200. So this is just trying to show you how your curve look like on a general view. So it's not a particular curve. It's not a particular log. It's just a curve. You understand? So, but what is of most value to us is these three logs that we are looking at on this triple combo at this moment. That is where our interpretation is based. So like I said, we want to do a cutoff. So we want to show clearly where our reservoir is and where is our non-reservoir. Looking at it like this, you and I can tell. We understand that you and I, we can tell where the reservoir is and where there is no reservoir. But I want us to put it there clearly. Let it appear on the log that this is the reservoir and this is not a reservoir. Okay, so how do you do that? We call that cutoff. So what we are doing now is just to put some cutoff values. So we are saying we are going back for us to define our cutoff value. We are going back to well, and we are going back to manage curve header. This is where we are going to define our cutoff value. If you go to statistics, you are going to take the mean because we are doing a cutoff. We want to determine the sand percentage, what is reservoir and what is not a reservoir. So we are going to use the mean of gamma ray. It is the mean that we are going to use at as our cutoff value. And when you look at the mean for gamma ray, you see that the mean for that gamma ray is 102. So every value from 102 and below is your sandstone or your reservoir. And every value from 102 and above is not a reservoir, it's your shale. So that's why we are coming back to this statistics. So when we do that, we already agree on that. So if we go back to resistivity, RT, we see that the mean is 6. So we are going to use a resistivity of 6 and above to be our hydrocarbon, and a resistivity of 6 and below to be water. So that's the mean value. That's what the mean is telling us. You can use other values based on studies that have been done within that basin. For example, the Rio de Janeiro basin has a very high resistivity values. If you come to the other basins, like different basins in different countries, you will not have the same. You will have to go and check the mean and see that the values are changing. So you need to know that. Okay, so let's close it. And then we go back to our scale bar right here. You click on that scale bar. You go to shading. You go right to shading. You go and select. You go and select curve name, and you select your gamma ray. You select your gamma ray. So that's the curve that you want to shade. That's the curve that you want to put the cutoff value. So you go to fixed value and put right here 102. You and I, we saw, remember that you are shading on your right because you said everything from your right to your left is your reservoir. That's why you are shading on your right. In other cases, you will not shade on your right. So it depends. So you're shading on your right because you're seeing everything from your right, from 102 to your left is your reservoir, and everything above that is your non-reservoir, which is shale. So on the shading type, you put something that represents a reservoir, which is yellow. And then you come right here and write reservoir rock. You can write reservoir rock right there. So once you do that, you click on apply. and then you can take yes to all. So once you do that, you have shaded, and everything that is your reservoir is clearly there. And what is non-reservoir is there. So it will shade just what is reservoir. Remember, you and I, we are shading our reservoir. We want to identify our reservoir on this log. So we have 2 clear reservoirs on our log. Okay. So we don't need any explanation to start explaining that, okay, this might look like it. You just go and feed it there, and you do a cutoff. You just go and fit your reservoir there, and your reservoir will come out clearly. You don't need explanations to start explaining that when you see this, when you see this. No, everybody sees this up there that this is a reservoir. These are reservoirs, and we can see 2 clear reservoirs here. So the next thing that you want to do is to go and do the same thing for resistivity by shading what is hydrocarbon and what is water. At the same time, you can decide that you want to shade what is non-reservoir, guys. So it's not just you shading what is reservoir. You can shade what is non-reservoir too. If you want to do that, you just go and click same there. You go back to shading. You click you put your gamma ray. But in this case now, what you do is that you are shading that the fixed value comes now to the left, because you are saying that everything that is 102 and above to the right is your non-reservoir or is your shale. So you write your 102 now to the left. You write your 102 to the left. To the left. Then you choose what you want to call non-reservoir. It can be this dark gray. I can call this dark gray as my shale. And then I put there non-reservoir rock. Reservoir rock. Non-reservoir rock. So remember that you can always you can always check things. If they don't work, you try it again. Okay, so if it doesn't work, try it again. Try some other thing. It will work. So that's it. So you needed to put your gamma ray here again. So it's not like you with this case for non-reservoir that you know that you're putting gamma ray, you're putting your value, and then you put gamma ray right here again. So when you do that, you click OK, and you have shaded what is a reservoir and what is a non-reservoir clearly on your log. It's very clear. So once you do that, you go to shade hydrocarbon. What is hydrocarbon and what is water? So you click right there, just like we did for reservoir and non-reservoir. You go back to shading. You go to curve name. You put your RT right there. You go to your fixed value. You put 6. And you come back here and put RT again. Then you go and take, normally we use red for hydrocarbon, right? And then you put the hydrocarbon. 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 So once you do that, please remember you have to shift it so that once you apply, you check it if it's okay. Yes to all, yeah. If it's okay, fine. That's it. You've shaded for what is hydrocarbon. Now, the next thing that you have to do is to shade for what is water. So what do? You repeat the same process. RT right here. In this case now, in this case now, water, 6, we'll have 6 right here. Water is usually represented with blue, and then you write there water. You click on apply, and there you have it. There you have it. There you have it, guys. So you have your, we can see clearly that our well log, we have 2 reservoirs. And with these 2 reservoirs contain hydrocarbon. And this hydrocarbon, we have 3 areas where it's filled with just water. And all the areas that are filled with water is a result of this shale. I mean, your interpretation is coming out clearly. Now, when you go to the last track, with the last track, we said it yesterday that where there is no cross plot, for you to know if that hydrocarbon, because remember that this is a cross plot of density and neutron. And whenever there is no cross plot, we do not have a balloon effect, then that hydrocarbon is oil. But where, in the case where we have a balloon effect, then that hydrocarbon is gas. And when we look at this reservoir very closely, we cannot see a balloon effect in areas where we have hydrocarbon. So we will say that, we will conclude that the both hydrocarbons or the both reservoirs contain oil and not gas. Now you need to remember that there is, when they are talking about balloon effect, they used to tell you that areas where there is shale, there is a presence of shale, can give you the presence of a balloon effect where you have shale. So do not confuse that balloon effect to be gas. But you will not confuse, because if something already is not a reservoir, then it definitely will not contain either of those hydrocarbons. So this is in the case where maybe, I don't know, but if something is not a reservoir at the end of the day, it's not hydrocarbon. There is no way you can call it hydrocarbon. So from this, just from this, our interpretation is very smooth. You don't even need to talk a lot. Every other geoscientist or engineer or petroleum engineer that picks it up will definitely see clearly what we are trying to define here. What we are trying to, I mean, you will see that, okay, this log has 2 reservoirs, and these reservoirs contain hydrocarbons. And from my interpretation, I can't see any balloon effect within those hydrocarbons. Then these hydrocarbons are oil. They are all oil and not gas. Now you will confirm your interpretation by the time you go to calculations and advanced interpretations, when you calculate the density of this, and you realize that the density is that of oil and not of gas. So these are things that you will use. You remember that science and engineering is about proof. You have to use a lot of parameters to prove your results. So you don't just use your qualitative interpretation and draw conclusions. No, you will add it there with the fact that even calculations of density tell you that the fluid within those reservoirs are oil. So you do calculations like that, and you have all of that. Now, the next thing that I want us to do is to separate these reservoirs. We need to pick the top and bottom of these reservoirs. We need to separate these reservoirs from, because if we leave it like this and we do anything that we want to do here, interpretation is going to show us that it's just a single, it's just, we are going to calculate it. So I want us to separate that the first reservoir is completely separated and different from the second reservoir. So that's what we are going to do next. Now, how do we do that? The first thing is for us to pick the top and bottom depth of these reservoirs. So we want to pick the top and bottom depth of this reservoir. We are going to pick this top and bottom depth together so that we'll write the values down. because we will input these values and this will help us to separate the reservoir. So the top, all you need to do is just to click your cursor at this point, and then you read it beneath, you read the value beneath. You realize that the top depth right there is 8,999. The top 8,999. So reservoir one. So reservoir one, R1 top is 8,999. R1 bottom. R1 bottom is 9,995. 9,095. So R1, the bottom is 9,095. R2, the top for R2 is 9,265. R2 top is 9,265. And the bottom for R2 is 9,316. So it's 9,316. So we have picked the top and bottom depth of these reservoirs. And all we want to do is to go and input those values so that we can separate these reservoirs actually into different zones. So how do we do that? We go back to well. We go back to well and we go to manage zone tops. We go to manage zone tops. So we click on manage zone tops. So once we click on manage zone tops, we go and click on new tops. We click on new tops. So we click on new tops and we give it a name. So we say reservoir zones. We give it a name right here, reservoir zones. Now, we come here, we said this is reservoir one. So the zone name is reservoir one. And then we have the top of reservoir one is 8,999. And the bottom is 9,095. Reservoir two, the top is 9,265 and the bottom is 9,316. So once you do that, you go to set zone colors. You go and set zone colors. You click on set zone colors. Reservoir one, you give it a specific color, which I will go for crimson, and reservoir two, you give it a specific color, and I will go for gold. So once that is done, you come and click OK. So you have it there, reservoir zones, the tops. Once you do that, remember that if you made an error, please, you can highlight this and click on edit zones to correct it if you made an error. If there's no error, you click OK. Your zone tops are already there. You click on close. You can close it. Those zones are already there. Remember that you can also export the zones. If you click on edit, zones, you can go to file and then you give it a name. That name can be reservoir zones. Can be reservoir zones. You give it a name and then you click. Okay, you go to output, sorry. You go to output, please, not file, please. You go to output, sorry. Click on output. Reservoir zones is already there, and then you click on save. So once you save, you can view, and those are the zones that you just save. And you can save it like that. You can keep your zone so that in the nearest future, you can just bring those zones inside. You don't need to go and be loading the zones again. You just bring those zones inside. Okay, so that's done. So once you do that, you just click OK, and then you click on close. We are done with that. Your zones. So once you do that, the next thing, you come in front of this gamma ray lock, you right click on it, and then you take a new track. You take new track. So you want to add another track on these 3 tracks that we have here already. So you click on new track. So once you click on new track, we want to insert these zones that we have just picked, guys. So once you click on new track, you click right here on the scale bar right there. So you click on that scale bar right there. So once you click on the scale bar, you go to shading. You go to shading. So you go to shading and go to shading description. So first of all, you go and choose okay, you go to style. So you go back to curve, sorry guys. You go to style and take zone. You go back to curve, you go to style and take zone. So once you take zone, you come here to color, line color, you select name so that it will give you the name of the zone. And then you can now go and select reservoir zone. You go to item, track item and select reservoir zone. That's it. Once that is done, you can click on apply. Okay, we'll repeat the process again, guys. We'll repeat it again. So that's it. So let me close. So I said the first thing for you to put in your zones, your reservoir zones on your lock. So the first thing is for you to add, you right click on your gamma ray in front of it, not behind here, please. In front, because you want to add another track in front of this track. So you right click and you click on new track. So once you click on that new track, another track will open like this. You go to this scale bar, you click right there. You go to curve. Under curve, you go right to style, which is the end. You go and select zone. Your style is empty, so you select zone right there. Once you select zone, you come here and select name. Once you select name, you come to track item and select reservoir zone. And then you click apply and then okay. And then you have it like that. You have separated your zones completely. Once you do this, you can start doing, or you can start checking the quality of each and every reservoir within your lock. You can start checking the quality. You can start doing all types of calculations, everything that you want to do with your well lock. But sorry, we are not going to if you want to sit here and go through IP, you have seen what IP can do. This is calculation, this is interpretation, advanced interpretation. So it's a lot that IP can do. So we just wanted to give you this introduction so that you see what IP can actually achieve. So it's really a very wonderful software that has really come to help research. Yeah, so normally it's very, very clear that you are going to learn a lot in the nearest future because Joe Savers will be organizing trainings. And we'll organize trainings and we are going to go into the details of IP. Every calculation, everything that this IP can do, every cross plot, every plot that this IP can do to check your results, we are going to do that. We are going to validate that. And so So I just feel like we have done a lot for today.